Okay, so EEPROM, the abbreviation is electrically erasable and programmable read-only memory. But actually, it is not only read-only memory; it is you can read and write. So there are several terms in the beginning. They just started and later they are unable to change it. One more example is RAM. RAM is actually read and write random access memory, but we are calling it as just like a random access memory. ROM is just a read only memory. Okay, so similar to that. Okay, EEPROM is just electrically erasable programmable read only memory, and this is also called as a flash memory, and it is a non-volatile memory. Non-volatile in the sense, when there is no power also, the data will be there, the data will remain stored, and it is an unlimited access. So it means several time you can write and you can read from it. There is no damage on reads, and it is a random access. So random access means so see, if you take the tape, because these terms and all they introduced because of the old technology. From old technology they introduced something new. Okay, see, for example, the old one is the tape. So tape record, how it will be accessed is it will start from the beginning only. Correct? No, if somebody able to remember the old tape recorder and all, you want to play a song in the middle, no? You have to forward and you have to play. I don't know how many of you this generation you guys used it, but when I was a kid and all, somebody used to be using this tape recorder. So it is a serial access only. Got it, right? You cannot now in mobile we have 10 songs, means we can go to any song and we can play. But in tape recorder you cannot do that. So 10 songs are there, means you have to forward the 5th song you want to play, means you have to forward 4 songs, then you have to go to the 5th song. It is because it starts from the beginning only, it will go in the sequence of order only. So this tape recorder and all, it is an early development for memory. So to overcome that, they introduced this random access. That is nothing but random access. Your RAM is the random access. It means the RAM, suppose in RAM you have 256 byte, means you can go and access the first byte also, you can go and access the 100th byte also, you can go and access the 150th byte also. Similarly, you can go and read. Everybody getting read? Here no need to go in order first byte, second byte, third byte, like that. So randomly you can go to any byte and write as well as you can read it. So that's the term a random access. So from this serial access, they introduced this random access in the RAM first. That is the reason that name itself they kept as a random access. But actually the RAM memory we are writing as well as we are reading. So it is supposed to be called as a read and write random access memory. But we are calling only random access memory. Okay. So similarly, this, see here also, this EEPROM. See, EEPROM, maybe right now you are getting, sir, what is EEPROM I will discuss. After that, where it is present, that I will come. So it is non-volatile, unlimited access, no damage on reads. It means n number of times if you are reading from that memory also, there is no possibility that damage will happen. But why they are mentioning this? No, the tape recorder and all, it will get damaged. So over the period if you keep using the tape recorder, no, after some a number of times, maybe it is 1,000 or 10,000 times, if you keep playing that same songs, no, over the period it will get damaged. Got it, right? That's the reason this they are saying it will not damage, because that time it was a big development. Getting right? So that it is still mentioned. So no damage on the number of reads, and it is a random access. Reprogram, rewrite. So it means this EEPROM memory you can write as a byte by byte or page by page. So page means sometimes people will call 4 KB as a one page. Sometimes like a 1 KB as a one page. It depends. But the general term is like a 4 kilobyte is called as a one page. So this EEPROM memory you can write as a 1 byte and you can read as a 1 byte. That is also possible. You can write as a 1 page and you can read as a 1 page. That is also possible. And you can write the whole IC. It means that whole EEPROM is like let's take it is 1 MB is there. That complete 1 MB also you can write and complete 1 MB also you can read. So all type of write and read is possible. You can do byte by byte, you can do page by page, you can do the complete IC also. These are all possible. Okay. And guarantee of 1 million erase and writes per cell before damage. So 1 million in the sense 10 lakh. Okay. So at least 10 lakh time it is giving the guarantee that you can write, you can keep writing into the memory. 1 lakh time if you are writing also there is no possible that it will damage. So till that they are giving the guarantee. Okay. So these all common features of EEPROM. Whether it is not particular to the PIC, anywhere like a EEPROM memory they are mentioning, flash memory they are mentioning, these all are like a common features. It's random access, also called as like flash memory, non-volatile, and no damage, and you can write and read byte by byte or page by page or complete IC, and 1 million time at least like you can write and read before damage. These are all common feature. Okay. Now coming to our EEPROM, that is in this PIC EEPROM. So the first day I have shown some block diagram. Hope you guys are able to see, no? Yeah, if you have, you can open that. So there is a two memory is mentioned. No? What is the two memory? Program EEPROM, data EEPROM. Okay. So program in the sense what program you are writing, that program is loaded into that memory. See, after writing program you are doing using programmer, you are loading your executable program, .x program you are loading, right? So that .x program is loaded into that program EEPROM. Everybody getting, right? And this data EEPROM is for other purpose. I will tell you, that is what today we are discussing. Getting, right? So today all discussion is about the data EEPROM. The program EEPROM, your actual the C program whatever you are writing, that is loaded into that program EEPROM. So how many bytes we have? Only 256 bytes we have, because already we discussed, right? So this PIC16F877A is a very basic controller. It comes with all are very minimal features. So even if you see the 256 byte only memory we have. So I used to tell, right, every time wherever it is needed only there you declare variable. Wherever it is needed 1 byte you declare only character. You don't declare integer variable. Because you see we have only 256 byte. Unnecessarily you are wasting 3 byte also. Out of 256 you are wasting 3 byte. That you have to keep in mind. Got it, right? That's the reason even in interview also people are expecting the best or efficient program. You should not waste even single byte of memory. Okay. So EEPROM is used to store the data, and the data are not erased even power is turned off. Okay. So that is data EEPROM. In program EEPROM you can write the program. So 256 bytes of data memory, data EEPROM we have in our PIC16F. Okay. And all these features are same applicable for this PIC EEPROM as well. Now, what actually now we are going to do is, sir, what is the purpose of using this EEPROM? See, the purpose is very simple. Your program is running. Keep running your program. For example, you are thinking that some important data you want to save it. See, whenever your program is running, only till that time that all data will be accessed, that all data will be used. Once your program is completed, so okay, your program is coming, so your program is running, from some sensor some data is coming, or from some other like a device some data is coming. That data you are using it, and your program is completed, your device power you are removing it out. Then whatever data you received, whatever data you processed, now that is gone. But what you are thinking, no sir, that data I want it permanently to be stored. Even next time when I am plugging in, next time again I am booting this device, again I want that data back. So from some device some data is coming, that you have to store it somewhere. Getting right? So you are storing for future reference. Future in the sense I am talking about, even power is plugged out, your data should be saved. Next time when you are plugging in, again you want the data, or you are using the data for some other purpose. Got it right? So you want to store it someplace. That is what is your data EEPROM. Okay. For other batch except 227, I think we discussed file operations. Got it right? The purpose of file operation. So when the program is running, all data is in the RAM memory. Once program is completed, everything will be erased. You want to store it somewhere in the permanent. Then you will store it in file, so that it will be stored in the hard disk. Correct, right? So here almost similar operation. Your program is keep running, you want to store the data in some permanent place. So you are storing into the data EEPROM, so that later you can use that data. Okay, fine. So today what we are going to do is very simple, just we are going to write some data into the EEPROM. Again, EEPROM is not anywhere outside, it is present. Within your microcontroller only is present. It is an inbuilt memory. In that inbuilt memory, you are going to store some data. Whatever so far exercise you have done, you are not used at all. Everybody getting right? So far all exercise we done, ADC, timer and the LCD, all this experiment you done, you are doing only the program memory. Your program you are writing, loading into the program is running, program completed means that's all. Now when program is running, we are planning to store some data for future reference, that's all. How to store? So we are simply like just taking one simple data and we are storing into the EEPROM, and again we are taking the data and displaying on the LCD. Simple experiment, nothing complex. Just whatever data we are storing into the EEPROM memory, that we are reading it and we are displaying on the LCD. Okay, so that's the experiment of today. Okay, so for this, just as usual, any peripheral, any like a component you are using inside that EEPROM, you need to do the configuration. Then only you will able to use it. So yeah, as usual, like you guys add this as include pic.h and as define XTAL frequency and that. Okay, and this global variable unsigned char byte. So these three things it is there. Okay. Next, void write byte to EEPROM. Okay. So it is a write function. This function is used to write into the EEPROM. From program, when the program is running, from the program you are writing into the EEPROM. Everybody getting right? So your program also is inside EEPROM only. From EEPROM, when the program is running, you are writing into the inbuilt memory data EEPROM. So this function is used for write operation. And this function is used for, from the EEPROM, programmatically you are reading it. When program is running, from the program itself is reading from that EEPROM memory. I hope everybody able to come into the context. Correct, right? So in your controller, you return some C program, that C program is loaded, program starts executing. During execution time, there is a one inbuilt memory data EEPROM. During execution time, some data you are storing into that EEPROM. And again, during execution time, and that data or some other data you are reading from the EEPROM. That's the experiment we are doing. So this function is used for write functionality. This is used for read. And this is as usual your main function. Okay. So now here we are using LCD. So for LCD, the two port we are using, port C and the port D. So this first line is for port C and D configuration. That's all. So ports address D is a configuration register, port D is just a data register. Anyhow, just you are initializing everything with 0. Okay. And the LCD init function. So these 4 functions you guys include it. I have not included. So LCD init function and LCD command. LCD command is 0x80 for first row, first column. And the LCD string you are displaying. Okay. So in the LCD, the string will be displayed EEPROM value something colon. It will be just waiting for to display some value. I hope till this everybody clear. Now coming to the while loop function, and you are calling write a byte. It means you are writing 1 byte of data into the EEPROM. So that's the meaning of write 1 byte to EEPROM. Here you are passing 2 arguments. First argument is what data you are trying to write. I am trying to write 7. You can write any number, just like a 1 byte data you give it, 0 to like 255 or any character, whatever you want to write, you give the data here. And the second one is which address location. So now how many bytes of memory we have? 256 bytes of memory we have, right? So in that case, what will be the starting address? 0x00. Then what will be the ending address? FF. Because starts from 0, right? Okay. So FF is 255. Since it starts from 0, so it goes up to 255. Is everybody clear? Out of that 0x0A, it means like maybe this will be 0x0A. So in this particular byte, you are writing the data 7. Clear everybody? Okay. So write function you are calling the data and the address you are passing as an argument for the write function. Coming to the write function. So data is received in the data variable, address is received in the address variable. And here you are receiving it as a const, because address you are not going to change anything inside the function. So you are receiving, even the data also you are not going to change, both you can receive it as a const. So, and then coming to the function, so here you have some registers. Okay, these are all register only. You are going to write the data and you are going to read the data. So in EEPROM, you want to write some data, means that data you want to put it in EEDATA. EEDATA is a 8-bit register. In this register, if you put some data, that data will be stored in that particular EEPROM. That's all. Again, which address you want to store, that address also you are putting in EEADR. These are all, it's a kind of configuration. Okay, like if you are using port C, means tris C and port C you are using for configuring, for putting data and taking data. So similarly, whenever you are using this EEPROM data, EEPROM means, so that time the EEPROM address, I mean which address you are trying to write or which address you are trying to read, that address you want to give it in EEADR, this register. Again, the data which you are going to put in that EEPROM memory, that you have to put it in the EEDATA, that register. Then automatically it will be stored in that particular memory location, that particular data. Clear everybody? Next, so this address and data you given. After that there is some procedure. Okay, it is not only just giving it, that you need to follow some procedure. So EEPGD you are making it as a 0. What is EEPGD? Is EEPGD, ECON1 is a one register, ECON1. So electrically that is EEPROM. Okay, EEPROM configuration register. You can consider like EEPROM configuration register. In this, EEPGD is program data EEPROM select bit. It means in our controller we have 2 type of memory. One is program memory and other one is a data memory. So now, which memory you are going to write? Are you going to write it into the program memory or are you going to write it into the data memory? That you are going to select. So now we are going to write in data memory. So access data memory. If you make this as a 0, you are going to access only the data memory. Okay. So that EEPGD we are making it as a 0. Next, WREN 1. WREN is write enable bit. It means like when that EEPROM you want to write, means this bit has to be enabled. Got it, right? So this write enable you are making it as a 1. And then econ 2. So this two numbers you need to put it for making this write operation to complete. So there is no any like a particular reason what is this number, all of that. Okay, that you forget about it. So the process is like what data you want to put, that you given, what address you want to put, that you given. Again, which memory, program memory or data memory. Whether write operation, read operation, write operation, so write enable you have done. Now to complete that write operation in econ 2, you have to first give 55 and immediately you are giving 0xAA. Once you give this, then actually your write operation automatically, it sets a procedure. So you don't try to decode like what is the number for 55, number for AA. So it's a part of procedure. So you need to give these two values. Got it? So you are giving these two values. And then WR you are making it as a 1. What is WR? Write control bit. So if you give 1, it initiates the write operation. Got it, right? See, the thing is, as of now what you have done, what you want to write, that you given, which address you want to write, that you given, and then you completed with procedure. Now if you make WR as a 1, now this all will actually go and write into that exact memory. So now you are initiating the write process by making WR 1. So WR is 1 means initiates a write cycle. This bit is cleared by order once the write is complete. Getting right? So the WR automatically it will become 0 once the write operation is done. Clear? You are making 1, but automatically it will become 0 because write is complete means it will become 0. Now you are going here, you are checking on EEIF is equal to 0. Okay, so EEIF is a EEPROM interrupt flag. Got it, right? But here interrupt we are not using. We are not doing anything on the ISR. So the EEIF flag we are using it. The purpose of using flag is once your write is complete now, automatically the interrupt will be raised. Okay, this flag will become 1, so that you are checking while EEIF is equal to 0 means still the write is not complete. So your loop is running here itself. When the flag is becoming 1 equal to 0 condition false. It means the write operation is complete. So it will come to the next line, and EEIF is 1 now, you are making it to 0. Because any flag, any interrupt flag, you have to clear it. Otherwise it will hit on the next other interrupt time. So you are making it to 0, then your write operation is, here itself the write operation is complete. Only the pending is like you want to make the flag to 0. Now flag you are making it to 0 means now write operation is complete. And again it will come back to your main function. Now you are calling read byte from EEPROM. So whatever we have written, now we are trying to read it. So read byte from EEPROM. Now which address you want to read? So since I have written in 0x0A, so I am giving 0x0A. That address only I am trying to read. Now coming to read function, again the address I am receiving it as a const char. Again which address I am trying to read? The EEADR I am putting that address. And then EEPGD, whether program memory or data memory, that I am putting. And then read operation or write operation. So since it is a read operation, so RD you are making it as a 1. So RD read control bit. RD if you are making it as a 1, initiates and read from EEPROM. RD is cleared by hardware. So here RD you are making it as a 1, and once the data is read, the data will be available in EEDATA, same place only. When you are writing or when you are reading, both you are going to use same EEADR, EEDATA only. So when you are reading, the data is available in EEDATA, that you are putting in the byte. Byte is just like a global variable. Okay. So in your normal variable you are putting, and then control is coming back here. Now you are moving the control second line first column, and you are trying to display it on the screen. Whatever you read, so it will be displayed on the second row first column. This will be process, it will be repeated. This you guys can make it like any other different way. You can write one like a text. So as a string you can write, and that string you can read it. But keep remember one thing, you can write byte by byte. Suppose you are trying to write bytes. So when you want to write bytes, then you should have a loop here. Got it, right? This is again just a programming logic, not anything related to the controller concept. So writing 1 byte procedure is this. Procedure is this. Reading 1 byte procedure is this. Now you want to write a bunch of characters or bunch of characters you want to read, you know. Here just you have to put some loop and you have to manage using your programming logic. That's all. Nothing related to the concept of EEPROM or concept of microcontroller. Clear, everybody? Okay. Okay.